Thank you all for hanging on for my session. This is the last of our virtual sessions today. And I will probably take about 25 minutes just to go through my talk. If there are any questions, we'll spend some time at the end looking at that. So hopefully this goes well because I've got so many tabs opened at the moment. So I actually thought very long and hard about what the learning objective for today should be. So before I started to put this talk together, I was thinking, what do I want people to walk away with today? And I came to the conclusion, I actually want you to leave today with more questions than answers. Now, I know that might seem a bit strange, but as we go through, I want you to start to think about the questions that pop up. Okay. So I don't want to give you the answers today. I want you to leave today with more questions than actual answers. So start to think of some questions that are coming up when we go through this talk together. So today, most of what we call artificial intelligence, computer vision, speech recognition, chatbots, recommendation systems such as Netflix, even agentic systems are all powered by machine learning. Now, machine learning is about building AI systems that learn from data. Let me say that again. Machine learning is about building AI systems that learn from data. AI technologies are transforming the world of work. There's no doubt about that. Today's workforce will need to learn new skills and also learn how to adapt. Things are changing very, very quickly. New ways of working are emerging. What happens under the hood? Well, under all AI systems, in a very simple, high level view, under all AI systems, you've got data, you've got maths, you've got algorithms. And it goes without saying the future is here, it's not going away, and it is powered by AI. So whether we like it or not, there's very little we can do about that. Okay, so before I wasn't sure about whether I should add this slide, but I think it's important before we go any further. What exactly is AI? Sometimes people use the term AI, and I sometimes sort of think, do they really understand what the term actually means? And there's been some people who actually refer to AI as A1. And there are examples of, I think it was an education minister in the United States who, throughout her talk, referred to AI as A1. And there's some very funny clips of that. So AI, it's an umbrella term. It's artificial intelligence. It's the broadest category. And it refers to systems designed to carry out tasks that normally need human intelligence, such as recognizing patterns, making decisions, understanding language, or solving problems. Now, AI is not new. The term artificial intelligence was actually coined in 1956 at Dartmouth Workshop. So, although AI feels very modern, the idea has been around for decades. But what has changed is the amount of data we now have access to, the computing power now available, and how advanced the models have become. But the term AI is not new. Now, machine learning is a subset of AI, and this is where systems learn from data rather than being explicitly told what to do. So there are two common types of machine learning. At a very high level view, there are two common types, supervised learning and unsupervised learning. In unsupervised learning, the model learns from labeled data. So it's important to understand the distinction. In unsupervised learning, the model will learn from data. So in supervised learning, the model learns from data. So we already know that the correct data has already been labeled. So, for example, if we want to train a machine learning model, we would say to the model, for example, this email is spam, this email is not spam. This customer has churned, this customer has not churned. So this is when it is actually been labeled. We're supervising the machine to learn via labeled data. In unsupervised learning, the data is not labeled. The model tries to find hidden patterns. So supervised, we label the data for the model. This is spam, this is not spam, this is a cat, this is a dog. We do the labeling for the model. In unsupervised models, the machine will try to find patterns. So that's machine learning. Deep learning uses neural networks. It's extremely powerful. It can do things, like create images, speech, and language. Now, what we think of when we think about AI, and when most people talk about AI, they're talking about generative AI. And this focuses on creating new content. I say new, and I've got my quotation bunny fingers here. It focuses on creating new content such as text, images, code, audio, or video. So these are tools such as ChatGTP, Claude, and Gemini. Now, some people, when they talk about AI and they talk about Gen AI, they tend to refer to it as AI slop. Now, I think that's a little bit unfair because if you understand prompt engineering and sometimes called context engineering, you can get amazing results from Gen AI tools. But there has been a lot of backlash. And there are lots of questions that need to be asked about these tools. Where has the training data come from? Was permission sought? Can I opt out? So there are questions to be asked about Gen AI tools. I don't like to refer to them as AI slop, but some people do. And also, as part of AI, you've got modern robotics like humanoids, self-driving cars, delivery robots, for example, all use AI. So the robot is a physical machine, but AI helps to interpret the world. It helps the machine, the modern robots interpret the world. So how to recognize objects, how to make decisions, how to respond to changing situations. So AI is a very umbrella term. And in that, you've got machine learning, you've got deep learning, you've got robotics, you've got Gen AI. Now, as I said, I don't like to refer to AI as slop, um, but AI machine learning modules can be very useful. I do think that when people talk about AI slop, they should clarify. And I tend to judge a little bit because AI is more than just chat GTP. AI is very valuable in industry, performing well when tasks are data driven. So if a task requires a lot of work with data, AI does very, very well. It can process huge amount of data very quickly. It can spot patterns humans might miss. It can make predictions or recommendations at scale. Businesses are using machine learning to solve real problems. In banking, it can help assess credit risk. It can find and look for fraud. So it's great for fraud detection, anti-money laundering checks. It can also improve customer service and operational efficiency. A simple business example might be customer churn. So a churn model could help predict which customer has the potential to leave us. Now, this gives a business a chance to respond early. If you know which of your customers might leave, you can respond early. So you might be able to offer more support, improve services, or target a retention campaign to try and persuade them to stay. Machine learning can really help businesses understand their customers' needs. So it's great at forecasting. It's a great at segmentation, so you can work with different customers at different times. So once again, when we talk about AI, it's more than just ChatGTP. It's about making better data-driven decisions. So I will talk about this in a later slide, but AI and machine learning skills are in huge demand. So learning AI and machine learning is not just trendy, it can be very practical. You can bring lots of value to a business and to your current role. These are skills that businesses increasingly want. They are being used across finance, marketing, healthcare. As you can see here, there is evidence that machine learning models are better at detecting breast cancer than the human eye. And there's several studies that have looked at this. So I actually think this is a really exciting field to be exploring. Tech is changing, but it's changing and there are increasing opportunities, I think, in data, machine learning, and AI. So data is the foundation. AI systems learn from data. This means the system's behavior is shaped by the data it was trained on. Let me just repeat that. The machine's system behavior is shaped by the data it was trained on. Quality and fairness matters. If the data is messy, inaccurate, biased, outdated, or missing important groups of people, the AI systems will reflect those problems. An unfair data set can lead to unfair decisions. Ethics matter. Ethical AI is not only about the model or the algorithm, it starts much earlier with questions like, where did the data come from? Who is included in this data? Who is missing in this data? Who might be harmed? No matter how advanced or impressive an AI system looks, it depends on the quality of the data underneath. If the data foundation is weak, biased, incomplete, or unfair, the whole system above is going to be affected. So if the foundation is biased, the system built on top will be biased too. So data matters. Now, data is the new oil. Data is extremely valuable and precious. Everybody is seeking to get our information and to collect data about us. Bias in AI systems doesn't just usually begin with the algorithm. It often begins earlier than that. It's in the data, it's in the history behind the data, and the choices made about what to measure. So I want to take a look at some examples of why data quality and fairness matters and how they can and have an impact on AI systems. So as we said, data is so precious. Some of you might have been playing Pokemon Go, but interestingly enough, it turns out that Pokemon Go, that era, was a massive unpaid internship. You were all data entry interns for the robot economy. There is no thank you, no email to say thank you for helping, no acknowledgement, nothing. A decade of unhinged behavior. We actually know that 30 million crowd-sourced images were collected during this time. So Pokemon playgoers were unknowingly helping to train delivery robots. So players who chose to do AR scanned helped create visual maps that were later used for robotics. Now, some people might say, well, does this really matter? But it's not always obvious if you can opt out. So sometimes people might have been doing this, not realizing that the data that they were, the game that they were playing was actually collecting data that is now being used for delivery robots. So the scans provided lots of views of the same real places from slightly different angles. And these people generated images are now being used to create dynamic 3D maps of the world. So robots can now compare what their camera sees against that map that was created by Pokemon Go players. The interesting thing is the data collected for one purpose is now being used for something completely different. So data can be collected at scale and it can be used, repurposed, and turned into something much bigger. And sometimes people don't realize that they can or they should opt out. It's just a game. It was just a fun game. Now, fair is not the default. Data sets are not always representative. So say hi to Shirley. This is something is called, here we've got what's called a Shirley card. A Shirley card was a reference image used once upon a time by many, many photo labs to calibrate color printing. Technicians would adjust the printer until the skin tone and the color patches on the card looked correct. I'm doing my bunny ears correct. Then use those same settings to print customers' photos. Because the cards usually featured a white woman, the standard for correct color was based on lighter skin tones. And this would often lead to poor results for darker skinned people. So in this time, if a family, if you look at old family photos of people with darker skin tones, they typically appear undeveloped. Now, it's just a photo. But change took a while. Change came to the consumer market when Kodak Gold in 1995 got lots of complaints from wood furniture manufacturers and companies who made chocolate. Their argument was, well, you know, the wood and our chocolate wasn't well represented in photos. And this is when Kodak decided in 1995 to actually take into consideration that there are a huge spectrum of browns. Legacy data sets, old data sets can have bias baked in. But it's not just about fairness, it's also about accuracy. So it's not just about fairness, it's also about accuracy. So let's take a look at how, if we don't have a wide range of people represented in the data set, it can be an issue. So a study in 2019 found that camera-based pedestrian detection systems using automated driving vehicles were less accurate at detecting darker-skinned pedestrians. A Georgia Tech study, the researchers found that across all their object detection models, performance for lighter skinned pedestrians was higher than for darker skinned pedestrians. And the gap stayed even after checking factors like the time of day or whether the pedestrian was visible. And they even actually said darker skinned pedestrians may be more likely to get hit because the tested models were nearly 5% likely to not protect them. So it's not just about fairness, it's also about accuracy. Another study in 2023, quite a large study, found that once again there was problems with people with darker skin, but the biggest issue was the problem with detecting children. Now, I've made a note here as well from something that was in the report, the 2023 report, that they were using over 8,000 images, and these images were labeled images. And the labeling is done by humans typically. And I just want you to start to think, what can go wrong when it comes to if things are manually labeled? So data sets might not represent everybody, and data sets might be poorly or inappropriately, not labeled appropriately. So start to think, remember, we want more questions and answers. What can possibly go wrong? Another example when data doesn't take into account everybody is crash testing data, which was historically built around the average size man. So the average male body was used to create and collate crash testing data. Even when eventually they did use a female dummy, it was often just a smaller version of the male dummy, rather than a true model of a female. Now, this matters because there is evidence that women face higher injury risk in comparable crashes, meaning a male-centered testing standard can leave important safety gaps. We know what gets measured gets protected, what gets ignored can be put at risk. So if you design around one type of person, the system may protect that group best and leave others at greater risk. Now, this is what can happen when data sets are not representative. So once again, we're talking about making sure our data sets are representative. Another example of when data sets and AI is used and not thought about, where has this data come from? Amazon discovered that its AI hiring tool in 2014 was not assessing candidates in a gender neutral way. The problem was that the system had been the problem was not that the system had been told to discriminate. So the system hadn't been told to discriminate. Nobody would do that. The problem was that it was trained on historical CV data. And that data reflected a tech industry that was very male dominated at the time. So you don't have to tell an AI system discriminate, but if your data set isn't representative or is biased, that will have an impact. So as a result, the model learned certain patterns from past hiring decisions and started treating those patterns as a sign of good candidate. So this meant it would favor CVs that looked more like the male-dominated data that it had been seen before and it had been trained on. So there were examples where if they saw in a CV the word woman or women's college or a woman's activity, I took part in a women's basketball team, those CVs were thought not to be great candidates. Okay. In the end, they got rid of this system. They realized that it was causing an issue, and they had to get rid of their AI recruiting tool. But we all know that applicant tracking systems are still being used. I saw somewhere the other day, I think it's around 98% of Fortune 500 companies still use AI to filter candidates. But I have also seen that some candidates now are trying to fight the system, and they're using something called prompt injection, which is very interesting. Um, because if a CV, a resume is being scanned by an AI system, some people are using white text to prompt inject certain things into their CV. So to the naked eye, it's not visible, and it doesn't look like anything's been done to the CV, and it's called prompt injection. So once again, we're looking at data sets don't just need to be fair and unbiased. Um, it's not just about fairness, it's also about creating greater accuracy. So all these people you can see here have something in common. They are all related now through something that has happened to them. Every single person here has been arrested or imprisoned because of mistakes made by facial recognition systems. Now, the biggest issue isn't that faces are hard to detect. In general, models can do this. Is that the system learns from data that is unbalanced, incomplete, low quality, or not representative of the people and the situations it will see in real life. So, if a facial recognition model is trained on far more images of some groups than others, it usually performs better on the underrepresented groups and worse on the overrepresented groups and worse on the underrepresented ones. And there's something in the news today, actually, about an AI facial recognition system that's been scrapped in the UK because of this. So if a model is trained on a disproportionate number of faces from one group or gender, it works better for that group and worse for others. Now, a second really big problem is image quality and conditions. Faces in the real world are not neat passport photos. They vary, the lighting condition varies, the camera angle, the distance, the blur, the resolution, shadows, expressions, all these things, make a difference. If the training and testing data don't cover all these scenarios and conditions well, the model will struggle and produce false matches or failures to match. So a lot of times you see models that are looking at facial recognition and building facial recognition systems have been trained, and the data sets have been used that are images of beautifully lit passport type photos. But that's not what the real world is like. Another issue is in how we label data. A model only learns from the examples and the labels it is given. So again, a model will only learn from the examples and the labels it is given. If images are mislabeled, that will be an issue. If they're poorly cropped, if there is inconsistency in labeling, that will also cause an issue. The model could learn from the wrong patterns. So the training data may not represent everybody equally. This will cause an issue. The images may not reflect real world conditions. This will cause an issue. And the labels might be poorly and inaccurate. So if you've got several people labeling images, you are reliant on everybody being consistent. So there are so many things that can go wrong if we don't think about them in advance. So facial recognition systems are often found not because faces are impossible to analyze, they're not, But because the data used to train them is often uneven, incomplete, or underrepresented, if some people appear less often or only in poor quality conditions, the system becomes less reliable for them. Data matters. The quality of your data matters. How you treat your data matters. Keep a quick look on time. So when AI and machine learning processes are represented visually, it's often depicted as a complex array of nodes strung together with, a sufficiently impressive looking lines crisscrossing and connecting layers of neurons. It looks as though it's all very scientific. We don't tend to think about the humans behind these systems. When we talk about bias in data and AI systems, we're really talking about human decisions. Someone decides what data to collect, who to include, what counts as the standard, and what gets left out. So if the data is incomplete or centered on only one group, the results will also be incomplete. The system may look neutral or scientific, but it's still working from a limited picture of the world. And that picture of the world is given to the machine by us humans. So whether it's Amazon recruitment, credit scoring, facial recognition, um, auto-driving vehicles, crash testing dummies, all of these things all require good data. Now, there's a saying in data science, garbage in equals garbage out. If you don't feed a machine learning model good quality data, you're not going to get good quality decisions out of that machine. So for an AI system to be most effective and for the best results, you need good data. You need to know how to collect, process, and handle data. So actually building a machine learning model is extremely straightforward. But the processes to get to that take time and they take a lot of practice and iteration. Data cleaning probably takes more time than actually building the actual model. So at work, no getting away from it, AI fluency and data literacy are central skills that are in great demand. Employers increasingly need people who can understand data, work with AI tools, and help make better decisions with both. There were so many reports that have been done, and I've only taken a couple here. The World Economic Forum Future of Jobs Report 2025 says AI and big data are the fastest growing skills for 2025 to 2030. It also identified AI and machine learning specialists and big data specialists as among the fastest growing roles. The OECD also said AI is becoming increasingly important in the workplace and is driving demand for both specialists, AI professionals, and people who can work and understand AI and machine learning. The UK government also have said AI citizens, we want everybody to have a foundation in data skills and to be able to engage critically with AI in work and in daily life. Once again, at work, data governance is a priority for all. Data governance is simply, quick look at the time, a means of having clear rules, responsibilities, and processes around how data is collected, stored, used, shared, and protected. Data strategies are everybody's business. It's about having a plan for an organization will use data to support its goals. Data is everybody's business. So very, very quickly, to start thinking about data strategies at work, and also to be going to work and saying, I want to bring value. And if we don't have a data strategy, let's talk about that. And I want to start to open that discussion. A data strategy will start with business goals, looking at the data that you already have, identifying gaps in data, skills, and tools, setting clear governance principles, how we handle data, where it lives, whose responsibility it is, how it will be used is also important. And also looking at what does success look like when it comes to a data strategy. The big takeaway is, and sorry if I've rushed it because I'm looking at time, is if we want better AI, we need to make sure that fairness is baked in. So when fairness is an integral part of your data strategy, your data starts to become more accurate. And when it's more accurate, it's more useful. So it's not just about let's be fair because that's the right thing to do. But when you are fair, when your data is unbiased, it becomes more accurate. When it's more accurate, it's more useful.